So, good morning. Let us start today's class. The chapter is Chemical Reactions and Equations from 10th Standard Chemistry. What are physical and chemical changes? Physical change. Change in color or state occurs but no new substance is formed. So, physical change. Example of physical changes: chopping of wood, melting of ice. Here, no new substance is formed. Second, chemical change. One or more new substances with new physical and chemical properties are formed. So, examples of chemical change: digestion, burning of magnesium ribbon, and etc. Observations that will help to determine a chemical change. Now, these are a few observations that will help us, that are evolution of gas, change in temperature, formation of precipitate, change in color, and change of state. When any one of these changes occur, we can definitely say that a chemical reaction has taken place. Chemical reactions are chemical changes in which reactants transform into products. As we all know, on the left hand side of the chemical equation we have reactants, and on the right side we have products. So the next point is types of chemical reactions. So these are the types of reactions in your curriculum, that is combination reaction, decomposition reaction, single displacement or only displacement, and the last is double displacement reaction. The reactions shown on the right side, that is redox, endothermic, exothermic, they are also types of reactions, but the main focus we have to do on the first four, that is combination, decomposition, single displacement, and double displacement. One by one we'll see examples of all these four reactions and study them in detail. Now, few symbols we have to use while writing the chemical reactions. That is, for solids we use S, for liquids we write L, for gases we denote it by G. When we have an aqueous solution we write AQ. When gas is produced in the reaction, that is when heat is released, we represent it by an upward arrow, and when a precipitate is formed we represent it by a downward arrow. Okay. Next, the first reaction which we are going to study is combination reaction. Combination, the name itself here explains what combination means. Combination means the combination of reactants to form a product. Here two or more reactants react and they give a product. As you can see, calcium oxide, CaO, calcium oxide is also called as quicklime. Here quicklime reacts with water, that is H2O, and a simple addition reaction takes place and we get calcium hydroxide, that is also known as slaked lime. Calcium oxide plus water gives calcium hydroxide, that is slaked lime, and here heat is evolved. So CaO plus H2O gives CaOH twice. In this reaction, calcium oxide and water combine to form a single product, that is calcium hydroxide. So combination takes place. So that is nothing but combination reaction. See, on the first figure we have calcium oxide in a beaker, and in second water is being added to that calcium oxide, and then this reaction takes place and we get calcium hydroxide. Second is decomposition reaction. Now decomposition, what is decomposition? It is a type of reaction which involves breakdown of single reactant into simpler products. Combination में क्या होता है? In combination, two or more reactants formed to give a product. Here reactant will be broken down into simpler products. So the example is calcium carbonate, CaCO3. Calcium carbonate is also known as limestone. It is being heated. After heating calcium carbonate we get CaO, that is calcium oxide, and CO2, that is carbon dioxide. So when limestone, that is calcium carbonate, is heated, we get quicklime, that is calcium oxide and carbon dioxide. This is an example of decomposition reaction. As you can see in this diagram, you are having calcium carbonate. With the help of a burner, we are heating this calcium carbonate, and you can see carbon dioxide is getting evolved. So this is an example of decomposition reaction. Third is displacement reaction. Displacement. In this reaction, more reactive element will displace a less reactive element. Displace matlab here shifting will take place. See the first example, iron, that is Fe plus copper sulfate, CuSO4. So here iron will displace the copper and you get FeSO4 and Cu. So FeSO4 is iron sulfate. You might have performed this experiment in your previous classes with the help of an iron nail. Another example is zinc plus copper sulfate. So here zinc displaces copper and it becomes ZnSO4 and plus Cu. So these were the examples of displacement reaction. Then see, this is the experiment which you might have performed. Here we are having an iron nail, copper sulfate solution. When we keep this iron nail in the copper sulfate solution for a few minutes, you will observe that the iron nail gets a brownish red coating over it. That is nothing but displacement has taken place. So this is the reaction. Fe plus CuSO4 gives Cu plus FeSO4. That is single displacement reaction. Now moving forward, the last one is double displacement reaction. In single displacement reaction, only one element was displaced, whereas in double displacement reaction, two elements will be displaced. Double displacement reaction. So the example of double displacement reaction is this: Na2SO4, that is sodium sulfate, when it reacts with barium chloride, that is BaCl2. So first displacement, that is Na2 and Cl2, that obviously forms NaCl, and that is twice NaCl. And then we have Ba and SO4. So here we got BaSO4. So Na2SO4, that is sodium sulfate, when it reacts with BaCl2, that is barium chloride, it gives barium sulfate and sodium chloride. As you can see in this diagram, a flask is being used, Na2SO4 solution is present, and then we are adding this BaCl2 solution, and after the reaction we will get BaSO4 and NaCl. Here a precipitate is also formed. Okay, thank you. Kindly subscribe to this channel Teaching Mantra, hit the bell icon and like our video. Thank you. See you soon.